Okay, so here is going to be a nice, happy rectangular equation. Y equals x squared plus 4.
Alright.
Right, what is that?
Well, using our formulas for y and x.
No. What is this?
Oh. This is a parabola.
This is a parabola.
It's a parabola. It looks like that.
Okay.
So, this is pretty easy to represent in our normal rectangular coordinates. Let's see what happens when it's in polar coordinates. So, r sine theta equals r cosine theta squared plus 4. So, r sine theta equals r squared cosine squared theta plus 4. Well, Because what we want is we want to get r's, all the r's on one side. So do r squared cosine squared theta minus that plus r sine theta equals 4. Well, this is kind of annoying because we have the r's. We don't have equal r's, so we can't divide everything out.
That's right. So ultimately we want to try to get this in the form r equals something. Function of theta. So how could we do that?
Well, we can just somehow get the r's kind of out of this side. I guess the square is kind of messing us up.
Yeah, it definitely is.
Well, I don't think we need to use calculus here with.
Yeah, it's not a calculus problem to go from. Here, let's back up. Let's go to here. Here's where we were initially. It's not a calculus problem going from here to here. R equals f of theta. It's a different. It's an algebra problem. So see if you can figure out what you need to do. What's the difficulty?
The difficulty is the r squared.
Okay.
So maybe we can. Taking the square root of both sides would just complicate everything.
Yep.
Dividing everything by r would not.
Yeah. Dividing everything by r is not going to help you.
Well, maybe we could. No.
What were you going to say?
Well, I was thinking maybe we could try to do something with cosine squared to put in another form, but
It's possible that helps, so that's not the technique you need here. It's not a trigonometry problem, it's an algebra problem. So you got this equation with r's in it, and you're trying to convert it into r equals f of theta.
so we need to isolate the thetas somehow.
Well, what's the issue?
The issue is the r squared.
Okay, so what are some things that you know how to deal with equations that have squares in them?
Well, taking the square root,
Okay.
but that's not going to help here.
Yeah, that doesn't seem to help.
doing quadratic things on them.
Okay, like what?
Well, maybe we could treat this as a quadratic in terms of r.
Alright, does that seem like that could make sense?
Maybe we could treat these as the constants, kind of.
Alright, so what does your equation look like then?
So we
Instead of
have,
moving the r's to one side, what would you do?
well, so I could have, we get a r cosine theta plus 4 squared and then minus 8r cosine theta on this side,
Okay,
and it equals r sine theta.
alright.
Actually, it's plus 2. Plus 2 and then minus 4. But I'm still not sure how this could help.
Yeah, I'm not sure why you're using a completing the square idea.
Well, you said not to move this to the other side.
No, I didn't.
It's still going to be rather complicated.
Okay, what is it gonna say?
So we're going to have r squared cosine squared theta minus r sine theta plus 4. So we have,
Finish writing the equation.
that equals 0.
Okay.
So we could use the quadratic formula here to say that r equals
Here, write it up here. This is gonna be long.
r equals sine theta plus minus square root of sine squared theta minus 16, 4 times 4 cosine squared theta, whole thing over 2 cosine squared theta.
2 cosine squared theta. Okay, so there you go.
But we get this is 2 equations.
Yeah, it is. So we'll figure out how to deal with that. But so what you want to do, it's hard to see that, but what you want to do is you want to treat this as a quadratic.
Mm-hmm.
These are the coefficients of the quadratic, and this is the form. So this is what the form is for y equals x squared plus 4. Again, this is not an obvious equation at all, what this looks like, especially compared to y equals x squared plus 4.
Yeah.
All right, so we'll look at that on the computer in a minute.